In this video, we're learning about how the solar system formed. So we'll cover what the original solar nebula was like, how gravity pulled material together, and finally how the sun and planets formed as well. Let's start by looking at what the original solar nebula was like. About 4.6 billion years ago, our solar system didn't exist as we know it today. Instead, there was a huge, slowly rotating cloud of dust and gas called the solar nebula. The nebula contained tiny particles of rock, ice, and metals, along with gases like hydrogen and helium too. And all these materials were created inside earlier generations of stars. Now, the solar nebula was absolutely massive and spread across billions of kilometers of space. At some point, though, something triggered it to start collapsing in on itself. Scientists aren't totally sure what caused it, but a possible theory is that it might have been due to shock waves from a nearby exploding star. Next, let's look at how gravity pulled material together during the formation of the solar system. Gravity is the force that attracts objects toward each other, due to their mass. And even though individual dust and gas particles are incredibly small, they do still have mass, and so they do exert gravitational forces on each other. So as the solar nebula rotated, gravity pulled all the material it contained inwards toward the center. This basically meant that small clumps grew larger as they attracted more material, and as they grew larger, their masses increased. As a result, their gravitational pull became stronger, which in turn meant they started attracting even more material. As gravity pulled the nebula inwards, the cloud began to flatten out and spin faster, just like how an ice skater spins faster when they pull their arms in. This formed a rotating disk, with material concentrated towards the center, and the center became much hotter than the outer edges of the disk. Finally, let's see how the sun and planets formed from this rotating disk. As gravity continued pulling material towards the center of the disk, the center region became incredibly dense and hot. When the temperature reached about 10 million degrees Celsius, nuclear fusion began. During the nuclear fusion, hydrogen atoms were forced together to form helium, and this process released enormous amounts of energy. This was the birth of our sun, and it contained 99% of the original nebula's material. The sun's energy created solar wind, which is basically a collection of charged particles that blew away gases close to the sun, and it's why the inner planets don't have much gas in their atmosphere. Meanwhile, the leftover material started to form the other planets in our solar system through a process called accretion. Now initially, this accretion started when tiny dust particles stuck together after they collided, but over time they formed larger and larger clumps called planetesimals, and these are the building blocks of planets. If these planetesimals were close to the sun, where it's much hotter, only rocky materials remained solid, and this is how the inner rocky planets like Mercury, Venus, Earth, and Mars were created. Further out though, where it was cooler, ice could form as well as rock and metal, and this meant the outer planets, which are Jupiter, Saturn, Uranus, and Neptune, grew much larger. And because these planets were much larger, they were able to capture thick gas atmospheres. This entire process took about 100 million years, resulting in the solar system we see today, all formed from that original disk of dust and gas pulled together by gravity. To finish up, let's take a quick look at some of the evidence for this theory of how the solar system formed. First, all planets orbit the sun in the same direction and roughly the same plane, which is exactly what we'd expect from a flattened disk. If planets formed randomly, we'd see some pretty chaotic orbits. Second, astronomers can see the same process happening around other young stars today, and we can directly observe disks that have planets forming within them.
If you haven't heard yet, you can find all of our videos on our website, cognito.org. You'll also find questions, flashcards, exam-style questions, and past papers. And we track all of your progress so that you always know what to study next. So sign up for free by clicking here, or browse our playlist here on YouTube.